Hello world, this is Krishna Chatur and this is the second Java video lecture. Today will be all about strings, input, and printing. Here's our project from last time. If you recall, in the first lecture we made a program to play around with integers and adding and things like that. So today we'll be making a new class. Let's call it strings and input. Once again, I'm not going to delete everything this time actually. I'm just going to get rid of the comments and get rid of the stuff on the inside. Our main method. Now, strings are just like integers in that they're also a data type. The difference is that instead of holding numbers, they'll be holding things like, well, letters and sentences. So for example, before I may have said int num equals 5. Now it's string, and note the capital S, that's important. String phrase equals good morning. It's actually evening right now, but no one cares. And just like how you can add and subtract integers, you can do certain functions with strings. I mean, you can't subtract them, but for example, I could say phrase equals phrase plus space followed by, I don't know, so notice I'm taking phrase, I'm adding the sentence with a space in front of it, and I'm assigning that new phrase to phrase. Now, at this point, it's kind of nice to be able to check what you're actually doing. And this is the point where I tell you that actually you can output stuff. There's a kind of cumbersome line, system.out.println. I'll explain what this means in a second. So basically, system is a class, out is like a, I'm not sure what out is actually, it could be a nested class or something. Not sure, but you don't really need to know. Println is a method. The ln stands for new line. I know it really should be nl, but no one asked me. So println, and then you're giving them phrase as a parameter in this method. If you're not sure what that means, basically a method is kind of like a function. It's if you've done math, you'll have f of x is equal to x squared, for example. And then in this case, f of x is the function, x is the input or the parameter, and then x squared is the output, or what you return. So in this case, println is like f of x. Well, println of phrase, rather, is like f of x. Phrase is what you're inputting, so x, and then the output is x squared. Or in this case, well, what do you output? You'll see that in a moment. So what this does is it prints to the serial monitor? I'm not sure what the right word for this is. Prints, let's just say prints for now. Well, later, once you start exporting your jar file, you'll end up printing into command prompt, but again, it depends. So if you want to actually print this out at this point, you hit compile, which, like I said earlier, turns your source code into bytecode. Then you close this, and you right-click on your class, hit void main string arrays. Other IDEs probably have different systems for this, but this is how BlueJ does it. Click here, ignore this. And if you notice, it's printed out phrase, this is our phrase, and it's all one neat pair of sentences. By the way, now that I've covered methods, it's probably best that I mention something I didn't get around to mentioning in the first lecture. There's actually a class called math, no joke, math, and there are some pretty useful methods and variables you can pull out of this class. Most of these are in data types that aren't integers, so I won't mention that until the next lecture, which will be about data types. But one thing that's kind of useful is math.pow, or power. And this lets you raise something to an exponent. So for example, I could say int num2 is equal to, let's say I wanted 5 raised to the 4th power. I write math.pow 5, comma 4. Oh, wait, sorry, let's make that num. So still 5, but I can change it later if I want. Now I want to know what that is, right? So I'll change this to num2. That's strange. Required int, now double. Oh, okay, I get it. Math.pow actually returns a data type that I haven't mentioned yet. Alright, well, I'll just do something called casting. I'll take whatever this is, which is called a double, by the way, a real number, and I'll convert it into an integer by doing this. Don't worry about it, I'll talk more about this later, but this is a useful technique for turning this into an integer. Now anyway, compile this, and we'll print out 5 raised to 4. So you go here, and that's 625. So if you're not sure what I just did, basically math is a class. It contains things you can use. Pow is a method in that class, like f of x, and this one takes multiple inputs, not just one, multiple parameters as they're called, and I can do whatever I want with them essentially, and it'll give me back whatever I need. Now if you notice, when I printed my thing out, I didn't have that previous string output there. It's because I checked this thing called clear screen and method call. This is very useful, and I highly recommend you check this immediately. Otherwise, it can become a nightmare remembering where the output came from and whether you should run it again or something. If you were wondering how you could learn about functions like math.pow and things like that without being telepathic, there's something called the Java API or the script API. It basically combines. Let's see, Java API. Well, actually, let's type Java math class. So basically what this does is it's their online documentation for all of these methods. They wrote everything down, right? So if you look online, they'll tell you what they can do. So go here, and a lot of this will make more sense later, but basically this is a list of all the stuff they can do. At absolute value, they can do arc, inverse, cosine, sine, tangent. They can do normal and hyperbolic trigonometric functions, ceilings, floors, exponents, a lot of crazy stuff. I mean, you could drive yourself nuts if you sat and went through all of this. There's one pretty useful thing I'd like you to take notice of, random right here. You don't use random very much in normal computer science, but you do use it a lot in gaming, and I'll be talking a little bit about making games later, so keep that in mind. Anyway, with that in mind, let's get over to the rest of this lesson. So there are two things you need to cover. One of them is taking input, the other one is tricks with strings. So let's start off with input because it's more interesting, in my opinion, of course. Maybe not as useful, but let's go here. So you have to import something this time. Import java.util.scanner. Basically, what this does is it takes a scanner class, a class that was written by someone else, someone in Oracle, and it lets you use that class. So this class is saved in your computer, but it's not actually in the program when you export it unless you ask it to be there. And it will be there because you need it. So let me get rid of all of this. We're going to start off by making a scanner object. Now I haven't really explained what an object is, but think of it kind of like a data type, like an int or a string. And I'll talk more about the distinctions between these later, but I said a lot, don't I? We'll make a scanner. So scanner, I'm going to call it console. You can call it KB for keyboard. You can call it, I'm just going to call it input actually. Scanner input equals, now this is the point where you assign the value to it, right? So, I don't want to sit and explain what a constructor is, but you know what, just type this. I swear you will know what this means later. But all you need to know is we're making a scanner and we're putting it in input, which is a scanner. That's all you need to know at this point. So we have our scanner. Now we can do things with the scanner, and the main thing we do with the scanner is take input. Now you can take integers and you can take strings and stuff like that with scanners. We'll start off with a string to keep it simple. So string phrase equals input, not scanner. Note I'm writing input because this is a scanner, and I'm running a method from it, which is why I'm putting that dot right there. So input dot, and the method in this case is called next line, and this prompts them for an input. It's at least BlueJ I know bugs up if you try to take input in the first line. So we'll print out a nonsensical line first. So we have that, and we'll take an input, and then we'll print it right back out at them. But we'll add on something else. We'll write take two. So we can distinguish between what they've typed and what we print back out. Now let's take a look at our fledgling program. We click this. Once again, we're importing a scanner class. We're using that to make a scanner. So this is blueprint for all scanners. This is a specific scanner we are making. Then printing some garbage out because we need to print something before we take input for some reason. And then we take their input. We take their input using this method and we assign it to the phrase string that we have here in a little container. And then we print that right back out at them. Plus an extra phrase. So if you notice, I can put these plus signs and stuff inside the method. It doesn't really care. Just make sure to nicely put a comma anywhere because that comma will mean there's multiple parameters and then you'll have some kind of problem on your hands. So we'll take this, run it, okay. So that printed out just fine. Now you can see it's actually waiting for an input. It's prompting me. So what should I type? Trolls tend to set off terrible tantrums in Tempest. And took the input, this is mine, and then it processed it and printed it right back. So we have a success right here. Now that our low-level success is complete, we can move on. Now that we have this, you may want to take a moment to write that down. That's 1 moment, that's 2 moments, done. Now that we have our scanner, let's do something a little bit more interesting. Actually, you know what? I'm going to keep that first line. Just get rid of that. Now, as you may have guessed, you can do a lot of fancy things with strings. You can. It's not just adding them, which is by the way called concatenating. You can actually do a lot more than that. So to find out what you can do, let's take a nice trip down to our friend, the script API. Just type string class or something. That should be good enough. Damn it. Alright. Now, where is this? Here. So char at returns the, we haven't really done characters yet, so let's get into that. But you can take individual characters out of the string. Let's see. We haven't gotten there yet. Huh. Man, this is all great for later. Oh god. Index of, that's a great one. Index of is you give it a character and then it tells you exactly where that is in the string. We will use that later. Actually, we'll use that very, very soon. Length tells you how long it is. Classic. Replace replaces every instance of, say, a V with a Q. If you really want to mess with someone, I don't know. Substring gives you a slice of the string to break it up very nicely. That's very useful, when you break things up with spaces to get words. Anyway, to lowercase, to uppercase, you get the idea. Trim gets rid of spaces on both sides. Let's see. You get the idea. So let's try out some of these to get an idea of how they work. And really, computer science, as you'll find out later, is more job of exploration and discovery than it is one of memorizing and learning. So don't feel unhappy when you find that there's a lot of things you don't know, because that's the point. You whenever you work on a project, you always kind of go out and learn whatever is relevant as you kind of go along. Anyway, so I have my phrase. What should I do with this? Whoops, looks like my video got cut there. My screen capture recorder thing doesn't really like long clips. Anyway, let's start off with index of. And we'll see why in a second. So phrase set index of, and I'll take it as index of A. Actually, make that B. And what am I going to do with that? So int, I use num a lot, don't I? I'm going to call it int index. So I want you to look very closely at what I do in this case. So I'm printing out the index of b, right, in whatever is given as an input. Now, when I run this and I type A, B, C, D, I want you to stop for a moment and think, what is going to get printed when I hit enter? The index of b, right? What is that index? I can't seem to highlight this. There. What is that index going to be? No pun intended. Ready? It's 1. Nope, not 2. I bet you were thinking 2. Unless you already did comp sci before. It's 1. And the reason for that is that A is 0, B is 1, C is 2, and D is actually 3 in this case. So basically what's happening is that every kind of listing thing or indexing thing in computer science will begin with 0. I showed you. Array indices will begin with it. If you're making any kind of system for yourself, actually, you'll find that like for loops especially will iterate from 0 and then to 1 less than your target. It's just more convenient to have that convention. Of course, when you print out numbers to other people, you'll add 1 to whatever you're thinking of at the time. It'll make more sense later. Oh god, I say that way too often. Anyway, that's index of. So if I type, let's do that one more time, but this time I'll type a lot of b's. If I type, so I've typed 1b, I've typed another b here, here, you can see it, here, another one here, and here, and here. Question is, which index is going to be printed out? 16, and that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This b right here, the first b, coincidentally, not coincidentally. So the index of the first one that you put in will always be printed out, basically. You can actually get something called last index of, and that'll print out the last one, but, you know, I'm not sure what I'm saying. Okay. Besides index of, we have substring. So I'm going to take substring of something. Oops. Now, I've forgotten what to put inside here, so back to the script API. Substring, click, click, click. There we go. So I can either take the substring from an index, damn it, here. So these lines. I can either take the substring from an index, or I can take the substring with beginning index and an ending index. And be very careful, the ending index will actually be the one after the last index of what they give you. You know what, let me explain this with code. Substring, let's take the substring from 3 to 7. Make that 6. So I'm going to print out, and not index in this case, it'll be string. I call it string piece. Now watch what happens. Oh, first things first, if I put something in really short that doesn't have 6 letters, I'll get an error, so don't do that. It's best to check for those things before you actually put them in your code, but this isn't exactly professional code, so never mind. Now, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. They give me D, E, F. So, one more time. I went for the substring 3 to 6, right? And 3 to 6 is giving me... Oh, why did I do this? It's giving me DEF. So that is 0, 1, 2, 3, right? Wrong one. 3, 2, 4, 5, 6. Oh, never mind. You know what? I was wrong. It is inclusive. So it does include 6. And no, wait, never mind. It doesn't. Nope. It's DEF. So 3, 4, and 5. 6 is not included. And you'll find that that kind of restriction is also imposed elsewhere. If you take things like a random number generator with, you know, lower bound 0, upper bound 20, it'll actually roll from 0 to 19. Anyway, now that we're done with that, the rest is pretty easy. There's length, so let's see, string length, what am I saying, string length, int length equals phrase dot length. Remember, you always need to put these right here. If it's a method, it's going to have these parentheses after it. If it's a variable, it's not. That's how you tell them apart. And I'll print out the length of the phrase ABCD. Yeah. When in doubt, comment it out. Got that. Four. So it's 4 letters long, as we would have guessed. Notice it doesn't say 3. 3 would be the index of D in this case, but it's not actually the length of the string. Length is still counted 1, 2, 3, 4. Confusing? Don't worry about it. Now we've got that. What else? Oh yeah. Comment it out. How would system dot to println phrase dot to uppercase? As you may have guessed at this point, give them a simple word, and it prints it uppercase. Numbers are of course unaffected, and there's an equivalent for to lowercase. I'm not going to sit and write it out. You get the idea. Alright, almost done. Just 2 things left. The first thing is that you should know scanners can take integer input as well, like specifically integer input. So I can write int, I don't know, their input is equal to input dot, remember input or scanner. Instead of next line, I'll write next int. And then I'll just print that out. And I'll add 4. Notice this doesn't print as a string. Actually, let me show you that. It's kind of interesting. So if I give them 5, for example. Oh, great. What have I done? No, that should be fine. Oh, I think I get it. Oops. Okay, let me do that again. I was taking a phrase first. Alright, get rid of that. Now I'll run it. So I'll give them 5, and it gives me a 9. So pretty straightforward. Now this begs the question of why is it that it's adding a 4 in this case, but it's not adding it like a string? In other words, taking 54. If I wanted that, I would actually take it as this. If I wanted 54, actually, I'd write their input. Actually, how did I do that? I put 4 in this, basically. I would take it as a string. So the moment I do this, 4 is no longer a number, it's a string. So if I were to compile that and give 5, now it's 54. Now what if I wanted to print 5 plus 4? Very strange to figure out this one. Well, what I would do is, and this is going to be a bit confusing, I'm going to put quotes around this whole thing and put another plus sign right here, meaning 5 plus 4. Plus 4 being printed. As a rough rule of thumb, anything inside the quotation marks is just printed verbatim with no modifications. And I'm going to break that rule right now, actually, but yeah, 5, and that prints out 5 plus 4. You can study this and play around with it a little bit more, get an idea of, how does this really deal with strings? Because strings are fascinating. Strings are kind of an enigma. They don't work the same way as everything else does. They're not really objects. They're not really normal data types. They're kind of weird. Anyway, last thing is next line. So you realize that if you want to go down a line and print in the next line, it's kind of a pain to type system.out.println every single time. So I'm going to show you a trick where you can do all that in one shot. You can put tabs in new lines. Let's say I want to print out, let's see, months of the year. So I'll write January, and then copy this, write February, then write March, you get the idea. Well, I can combine those actually. I can just go up here and watch this carefully. January, \n, February, \n, March. And we're thinking, this is impossible, that is never going to work. Well, guess what? Doesn't matter. Oh, integer, damn it. Try it again. It works. That's right, it works. The backslash is called an escape character, meaning whenever the compiler sees a backslash, it goes, oh, that's a backslash. The next character is not what it seems. And then depending on what you put after that, it acts differently. So if I put an N, that means go to the next line. If I put a T, that means tab it. So watch this. T, compile. Oops. So fun to look at that. Huh. That's strange. What have I done? Oh well, I guess you can't really argue with randomized tabbing. Anyway, let's combine all of these. So I'll take a string input rather, with, let's see, string phrase equals input.next line. Take a piece of it, and I'll take its length. Then I'll print everything out in one go. So I'll print out original phrase. I'm putting a space after the colon, note. And then I'm adding on phrase. Then I'm putting a new line, and then for the sake of readability, I'm going to add another plus right here. I don't need a plus, but it's easy to read, so then I'll put, let's see, length, and length goes right there. And then I'll put another \n. You know what, I can combine these, not going to kill anyone. And let's see, substring 3 to 6. You know what, even when you're printing things, it's best not to use lowercase for that. Best not to use uppercase for that. 3 to 6. I know this is turning into a mess. Well, you get the idea, basically. And then I'll print out piece. And then finally, I'll print it out in lowercase. And that'll be phrase dot to lowercase. Huh, it compiled. What do you know? Let's see, is there anything else I need to put here? No. Oh, you know what? Let's just put a tab right there instead of a space. See what happens. Who knows? No, actually that's a terrible idea. What was I thinking? Alright, compile, close, run. Nonsensical line first. How many boards would the Mongols hoard if the Mongol... You know what, that should be capitalized. Goes forward if the Mongol hordes got bored. There we go. And the answer is... Whoa, what was that? Oh no, that's right, yep. That's my original phrase. That's the length of it, 71. I'm not going to check and count that. So string from 3 to 6 is MA. Check 0, 1, 2, 3, space, right? And then M and then A. So that's actually a space right there. Lowercase, and that destroys my grammar. Alright. And that concludes today's lesson. Stay tuned for more, and thank you for watching.